All right, this is the review for the quiz tomorrow worksheet we got yesterday. So we're just going to go through these questions, and then if you guys have any questions, let me know. So number one, we'll talk about it tomorrow if you have questions. We're taking a look at this function. Now remember, they give us the first term, and they give us an equation that has an n minus 1 in it, a big N minus 1. So this tells us this is a recursive function. So in order to do this, we need to figure out, if we want to figure out what f of 5 is, okay, we're going to need what f of 4 is before that, and we're going to need to know what f of 3 is before that, and then we need to know f of 2 to get f of 3. So remember, this is the current term, and this n minus 1 represents the term before it. So if we want to do f of 5, we have to work backwards, okay? So f of 5 is going to be negative 2 times f of 4 plus 1. F of 4 is going to be negative 2, and then n minus 1, and it's going to be 4, so that's going to be 3, times f of 3 plus 1. Negative 3, you guys get the pattern, is negative 2 times f of 2 plus 1. So f of 2 is negative 2 times f of 1. 2 minus 1 is 1, and then plus 1. So we already know that f of 1 is 3, so we can just do negative 2 times 3 plus 1. And so this is negative 6 plus 1, this is negative 5. That's f of 2. So we're going to plug that in right here. So it's negative 2 times f of 2 is negative 5, and then plus 1. So 2 times negative 5 is positive 10, so plus 1. So that means f of 3 is 11. Okay, we're going to plug that in right here. So this is equal to negative 2 times 11 plus 1. So this is negative 22 plus 1. So f of 4 is negative 21. And then we're going to plug that in here. Negative 2 times negative 21 plus 1. 2 negative times negative is positive. This is 42 plus 1. So f of 5 is 43. And that's our answer. Okay, so this is a recursive function. Number 2, right next door in the sequence, the first term is 4, the common difference is 3, the fifth term in the sequence. So we can either say to ourselves, okay, I want to know the fifth term. I start at 4, and then I'm just going to add 3 multiple times in order to get there, and we can figure it out this way. Or we can do our a sub n equals a sub 1 plus n minus 1 times d formula. So your call. Okay, we'll walk through this one since we're getting used to these formulas. So a sub n is equals the first term, which we know is 4, plus n minus 1 times 3. So if we plug 5 in for the fifth term, this is going to be 4 plus n minus 1 is really just going to be 4 times 3. 4 times 3 is 12. 12 plus 4 is 16. And we can get the idea here. If we add 4, we're at 7, 10, 13, and then 16. So either way, we should get the same answer. Okay, this, once again, has the n minus 1 in it. Okay, so remember that means that it is the first term and an n minus 1. That is a recursive function again. So if we want to get a2, we're going to have to take 3 plus 2 times a2 minus 1. This is a1 squared. So a2 is equal to 3 plus 2 times a1, which is 6 squared, 36, right, times 2. That's 72 plus 2 plus 3, so that's 75. What is the common ratio of the geometric sequence whose first term is 5 and third term is 245? So remember, we know that in order to get from one term to the next, we have to multiply times something, okay? To get there, we could say r if you want. We're multiplying times the common ratio to get from 5 to 245. Now, it's multiple choice. You could just say to yourself, if I multiply by 7 and then times 7, do I get this answer? But remember, we talked about doing like this in class. So this is 5r squared equals 245. We'll divide by 5. R squared is going to equal 49. And that means r, when you take the square root of 49, is going to equal 7. Okay, give the following 3 sequences. Which one is arithmetic? So remember, that means we're adding. So you can see as we go from 2 to 4, 4 to 6, 6 to 8, this is adding 2 every time. 2 to 4, 4 to 8, 8 to 16, this is multiplying by 2. And plus a plus 2, a plus 4, a plus 6. This is actually, you can kind of think of this as a plus 2 plus 2, a plus 4 plus 2, right? So this is also adding 2. So which of the sequences are arithmetic? It would be 1 and 3 only. Okay, in the main floor of the Kodak Hall of the Eastman Theater, the number of seats per row is a constant rate and increases at a constant rate. Stephen counts the 31 seats in row 3 and 37 in row 6. So you can kind of think to yourself here, there's, right, 6 rows. So we'll make 6 blanks. We know the third row has 31 seats. The sixth row has 37 seats. So how are we getting from, and it's increasing at a constant rate. That tells us it's arithmetic. So what are we adding to get from these, right? And it's like a difference of 6, and there's 3 spots, so we'd have to be adding 2 each time. So we can kind of work backwards to figure out how many seats are in row, going backwards here to get our answer. So we want to know in row 20. So if we walk backwards, we're going to be at 29 and 27. So that means A1 is 27 and D is 2. So if we want to know in row 20, now we can use our A sub n equals A1 plus n minus 1 times D formula because it's arithmetic. So this is going to be 27 plus n minus 1 times 2. And then we want to do A sub 20 for the 20th row. Okay, that's a 20 down there, by the way. So 27 plus 20 minus 1 is really 19 times 2. So A sub 20 is going to be 27 plus 38. And this is going to be 65. And there's the answer to number 6. Okay, whether this is exponential or linear. So remember, exponential just means it is also geometric. So since we can see that we're going from 1 to 3, 3 to 9, 3 to 27, this has an R value of 3. So we can say, yes, it has exponential behavior. Since the sequence multiplies each term by 3 to get the next term. You could also have said something about it being geometric, okay, as well. Or you could also say the formula, remember, is 1 times 3 to the whatever power. So it also follows that format. All right, same thing here. So number 1, we want to identify what type of sequence it is. We can see that we're just subtracting 4 each time. So this is arithmetic. We want to know what f of 6 is. This is just like saying we want to know what a6 is, okay? We also want to know which function defines the sequence. So if we started with this formula, okay, if we just distribute and solve, we'll get our answer, okay? This is like saying y and x. So plus n minus 1 times d. This is like saying y equals the first term plus x minus 1 times d. This is all we're doing, okay? So we know the first term is -6. And then x minus 1, and the common difference is -4. So we can just distribute the -4 through and combine like terms. -6 minus 4x plus 4 is going to give us -4x and then -2. So we choose choice 2. You could also think about it in terms of plugging in the function. So if we made an xy table here, When x is 1, the first term is -6. The second term is -10. So if you plug in 1, which one of these is going to give you -6? Okay. So you can kind of keep that in mind, right? Oh, sorry. I just noticed if we plug 1 in here, we're going to get 4 minus 2, which is 2. It's not 2. It's actually choice 1, -4x. All right. This one doesn't work. That one doesn't work. This is the only one that gives us -6 when we plug 1 in for x. So you can kind of use that to also help you solve those questions. Okay. Number 9, in the diagram below, represent the first 3 terms of the sequence, assuming the pattern continues, which formula a sub n, the number of shared squares in the nth term. So if we take a look at the shared squares, there's 4 here. There's 4 on the outside, so there's 8 altogether. Here there's 3, 6, 9, 12, and then 4 inside, so that's 16 altogether. Now it sort of looks like you could be multiplying by 2, but you could also be adding 8. You want to get the next term to really see what's going on. So 4, 12, 16, 20, and this is 24. So now we can see we're definitely not multiplying because this should be 32. Instead, we are adding 8. So this is arithmetic. So just like the last one, we're going to take our formula, we're going to plug in, and then we're just going to solve, right, distribute through to get which one of these works. You can also use your XY table here, right? I know that the first term has 8, the second term has 16, and the third has 24. Which one of these actually models that data? If I plug 1 in here, I get 16, so this doesn't work. If I plug 1 in here, I get 12. That doesn't work. If I plug 1 in here, I get 8. This works, right? 4 plus 4. And this is going to give me 6, so this doesn't work. So it has to be choice 3, because it's the only one that actually gives me the number of squares for this, okay? So just keep that in mind. Time out. Time out. 2, 4, 6, 8. 2, 4, 6, 8, and 4. This is wrong. This is 12. 3, 6, 9, 12. 16 works. 1, 2, 3, 4. 16. That works. 4, 8, 12, 16. Oh, 20. Some of you guys are probably looking at this video being like, stop the video. You are not, this is not correct, Mr. Z. And hopefully we're catching that. And you can kind of see that I got this with an error. And if I would have plugged in correctly, I would have also not gotten one of these answers. So I would have double checked where it's actually adding 4. So if we fix this, this is 12, 16, and 20. We might get a little different result here. So let's try this again. If we plug 1 in, we're going to get 16. That still doesn't work. If we plug 1 in, this is going to give us 4 plus 8, which is 12. This does work. If we plug 1 in, we're going to get 8, which doesn't work anymore. And if we plug 1 in, we're going to get 6, which doesn't work anymore. Now, if we substitute into our explicit formula, the first term is 12 plus n minus 1 times d, which we know is adding 4 here, and we just distribute the 4 through, we're going to get a sub n is equal to 12 plus 4n minus 4, and then a sub n is equal to 4n, and then 12 minus 4 is positive 8. So that's why that formula is also working. Okay, we have an exponential equation here. So number 1, we have talking about increasing or decreasing. This is going down. So that tells us that we are doing a decay. All right, so remember the b, the growth or decay factor is 1 minus r. So let's keep that in mind. So the formula is y equals ab to the x. A is our initial amount, so that is 12,000. B is our 1 minus r, and our rate is 6.5%. So remember, we're going to divide that by 100 and get 0.065 for the decimal. We can't use the rate, okay, as a percent. We need it as a decimal. And then x, which is the time, is in years, and that's 5 years. So b equals 1 minus 0.065. So b is equal to, and if we're taking away here, we should be at 0.935. So 6.5% minus 100 from 100%. Yep, is 0.935. Okay, so this is going to be what we're plugging in. So we're plugging in A, we're plugging in the B that we got, and we're using X. So just off to the side, Y equals AB to the X. Y equals 12,000 times 0.935 to the 5. I want to see the formula so I know what you're plugging in here, and then we can go ahead and we can evaluate that. All right. So just gritting up the calculator real quick. So 12,000 times 0.935 to the 5, and we get $8,575. And it doesn't say what to round to, so since it's money, we're going to round to the nearest cent. So that's $8575 point, and we have 10 cents here. 0.10. Next number after the zero is a 2, so we're going to round down and keep it. Okay, number 11. The third term in arithmetic sequence is 10. The fifth term is 26. If the first term A1, what is the equation for the nth term in the sequence? So remember, we need to use our fact that we're going from 10 to 26 over 5 spaces to figure out D. Okay, what does D equal? We can also use our chart we talked about before. The first term is 10. We plug 1 in. Which one is going to give us 10? All right. Oh, sorry. Third term. Third term is 10. The fifth term is 26. So when x is 3, which one is going to give us 10, right? So 3 times 8 is 24, plus 10 is going to be too big. This is 24 minus 14. That will be 10. This is also going to be too big, okay? And then this is 48 minus 38. This does give us 10. So these two could be possible answers. And then if we checked 5 is 26, now we can kind of get an idea of which one's going to work. So 5 times 8 is 40, minus 14 is 26. 16 times 5 is 80, minus 38 is 42. So that's too big. So we would know the answer is 2 just by substituting in 3 and 5 and see which one works. But if we work through this, I know that I'm adding 2 numbers to get from 10 to 26. Okay, so you can think of it as 10 plus D plus D. I'm using D because that's the common difference, is 26. We can subtract the 10 over. I get 2D is equal to 16. And then when I divide by 2, we'll have our answer here. All right, so divide by 2, we get D is equal to 8. So I'm adding 8 each time to get from one term to the next, and then I can do my formula. A sub n is equal to the first term plus n minus 1 times D. So A sub n, we got to work backwards here. So we have to go back 8 to get 2, and then go backwards 8 here to get negative 6. So negative 6 plus n minus 1 times 8 will distribute through. So a sub n is equal to negative 6 plus 8n minus 8. And we'll get a sub n is equal to 8n minus 14. So either method of plugging in or using your formula will work for you here. Okay, this is a recursive function. Okay, so remember, we want to know what are we doing to get from one term to the next here. So if you look at the function, how are we getting from one term to the next? Now, this is obviously not going to be arithmetic. This is geometric. So what we need to know is what are we multiplying by to get from one term to the next. So remember, If you take A2 and divide it by A1, that will equal R. A3 over A2 will also give you R, okay? So if we just do 20 over 50, sorry, 20 over 8, because that's the term before it, okay? We can reduce this down. You can take a 4 out of both, and we're going to get 5 over 2, which is 2.5. If you do the same thing for 50 over 20, you can take a 10 out of both, which is 5 over 2, or 2.5. That's our R value. So the sequence should be, okay, it's the term before it, so A sub n minus 1 times R. That's the geometric formula. Give me the first term, okay? A sub 1 equals what? And then here it's 8. And that's what they told you in the question, okay, right here. And then what is this? So it should be A sub 1 times R, and R is 2.5. So this is out because this is not the correct formula. This is also out, and this is the wrong R value. So it should be choice 2. All right. 13a, we're going to graph the function on the set of axes below. So once again, we're going to take our calculator, open up graph. We're going to type in 2 to the x, and then minus 7 here. Now remember, minus 7 takes the normal curve, the normal exponential, and just shifts it down 7 units. So what I need to do is I can't actually see these numbers, and that's okay. We're going to graph it. We really want to go to the table. So remember, we kind of want to pick numbers that are going to fit on the graph. So 4, 9 will fit, right? 1, 3, 1, 2, -3, 1, -5, 0, -6, and then we can see we're getting pretty close to just heading towards -7. So I don't really want to go below -2 here. If you wanted to change your window, remember we go to Menu, Window Zoom, and then Settings, and we can change this Y minimum to just be something bigger than this, or lower than this. How about we choose -10 and hit enter. And now we can see the curve better. So something along the lines of -2, -1, 0, right? 1, 2, maybe 3, and that'll be about it. Okay, so we're going to go back here to our table. So we're going to do x, y table here for ourselves. We said we're going to pick -2, -1, 0, 1, 2, and maybe we'll do 3, depending on how much room we have. And we'll plug it. So at -2, we're at -6.75. At -1, we're at -6.5. At 0, we're at -6. At 1, right, we're going to be at -5. At 2, we're going to be at -3. So we do want to kind of probably put another number in here just so that we can get above the x-axis and kind of see where we're heading. So we will include 3. 3 is 1, and then 4, if we want to put it, is 9. Okay, so 1, 2, 3, we're at 1. We know at 4, we're at 9. Okay, so we can put it up there for ourselves, and then we know we're heading down. So -2, or sorry, 2 is -3. 1 is -5, -6, -1 is 6.5, and 6.75. Now keep in mind the graph looks like this. We want to draw that asymptote in. So don't just draw a graph that heads like this and then put an arrow going down. That looks like the graph is going to continue down in this direction. Make sure you draw that asymptote in. Okay, so heading down through and then along this line. All right. And then you can throw your arrow on, indicating that we're going to head in that direction. And then we're heading back up. So we're just going to connect the dots here, draw our curve in. Now, if you just wanted to do this, we know we're heading in this direction, that's totally fine. Okay, so we didn't have to graph 9, but we will graph 9. We put it on our sheet here, so we're going to graph through there, heading down. Okay, do I need to have on, remember, do I need to label the lines? Not currently, because I only have 1 on the graph. All right. However, the next question is g of x okay, is to graph g of x. So this is f of x, f of x. We're going to graph g of x. So starting with y equals 1.5x minus 3. This really is, right, 3 over 2x minus 3. So this is the linear equation. So I need to know the y-intercept and the slope. So the y-intercept is negative 3. The slope is 3 over 2. If you got confused, just go ahead and we can drop the table on for now. Tab, right? Negative, oh man, freaking out. Negative 1.5x and then minus 3. All right, there's our line. And now when we go back to the table, we know we're going to be right over here picking those values. And then just graph a couple of them that are nice numbers and draw your line in. I know I'm going to make a dot at negative 3. I'm going to go up 3. Okay, timeout. Our line is definitely not graphed correctly. And that's because we did a negative 1.5. This should be positive 1.5x. So the line should flip that way. There we go. Okay. So up 3, right 2, up 3, right 2, up 3, right 2. We're going to get this line right here. All right. And then the same thing, we can go down 3, left 2, down 3, left 2, and draw that line in for ourselves. All right. And so this is g of x. We probably should put the equation here. So negative 1.5x minus 3. And f of x was 2 to the x minus 7. Okay, so what it says is f of x greater than g of x when x is 4? Okay, so if we go to where x is 4, 1, 2, 3, 4, here's 4. So if we look along this line right here, this is x equals 4. Is f of x greater or g of x? Which one has the higher y value? Okay, so we would say f of x is greater than g of x at x equals 4. Okay, and we can just say since the y value of f of x is greater than g of x. Remember, the f of x is the y value. This is 9. G of x is 3. So 9 is bigger than 3. Okay? So you could also have explained that. F of 4 is equal to 9. G of 4 is equal to 3. That's how you evaluate the functions. And then we know f of x is bigger because 9 is bigger than 3. That's another way to say this. For number 14, we're going to graph 2 to the x. We're only graphing it over this interval. So we are going to include endpoints. We're not going to go beyond -1 and 3. We're just going to graph from -1 to 3. So when you make your table, okay, I'm only going to include these values: -1, 0, 1, 2, and 3. That's it. Okay, so -1, we plug it in, and you can use your table on your calculator as a half. 0 is 1, 1 is 2, 2 is 4, and 3 is 3, 2 to the power of 3, which is 8. Okay, but all we're going to do here is just graph. So we can just go new document. No, I would not like to save. Calculator, 2 caret x. Oh, that's not a calculator. What is going on? Okay. Yeah, okay. 2, new document. Try this again. No, I don't want to save. Graph, not a calculator. 2 caret x. Enter. And there's my chart. There's my graph. Here's my table. And I'm just going from -1 to 3. That's it. Okay, right there. There's your window. So I'm only going to graph these points. So at -1, I'm going to go to a half and put a dot. 0 is 1. 1 is 2. 2 is 4. 3 is 8. I don't go beyond these. So that's all I'm going to do is draw the curve from here to here. Stop. That's it. And we have n points on the end, points on the end. That's it. That's the curve, okay? All right. Will this graph ever intersect the x-axis? No. The graph does not reach the x-axis. We could even go even more, and we could say that the graph of y equals 2 to the x, right, actually has an asymptote at the x-axis and doesn't reach it at all. So we could say that, but this is fine for what purposes we need. Okay? Number 14, Mr. Z inherited a savings account. Yes. All right, started by his grandmother when he was born. Considered the function a of t equals 1200 times 1.025 to the 40. Let's get the value of the savings out on Nora's. Oh, we forgot to change Nora away to Mr. Z. Get out of here, Nora. Okay, identify the following. What was the initial amount that we invested? So remember, in our formula, y equals ab to the x, the initial amount is always the a there. So that would be 1200. Right? What was the rate the money increased by? Remember that the b factor is equal to 1 plus r. So 1.025 is equal to 1 plus r. So if we just subtract 1 away, sorry about that, we'll have our rate, which is 0.025 or 0.025. That is our rate. Okay? This is 2.5%. or 0.025. I'll take either one. How old am I? Remember, this is our time. So if I got it when I was born, now 40. Okay, and the value, we're just going to type this into our calculator and get our answer here. So if you have a graphing page open, you can just hit home, and then you can actually press the calculator button down here at the bottom. All right, and it will open up a calculator page for you. You don't have to necessarily open a new document every time. And we're going to do 1200 times 1.025 raised to the 40. I got a little bit of money in there, right? $3,222. This is money. It doesn't say what to round to, so we're going to the nearest cent. 0.0, and since the next number after a 7 is a 6, we round up, and 0.08. All right, couple of transformation functions. So we want to take the graph of y equals 2 to the x. We're going to reflect it over the y-axis. Remember, that means we're going to change the sign of the x. Left 3, so that means we have to actually add 3 to the x, and down 2 means we take f of x and we subtract 2 from it. So the function should be f of x equals, change the x. So it's 2 to the negative x. We add 3 to it to move left, plus 3. Okay, and then we go down 2. Now, if you're on a test or equation, you have time, you could graph the two functions. Okay, you could graph the two functions. So Control plus to add a page, go to graph. Could graph 2 caret x. And the reason this is my caps lock is on for some reason. All right, and then we enter in our function. So we can just do 2 caret, right? We did negative x. Oh, we got to press tab first. 2 caret negative x. Get out of here with the caps lock. That's okay. But parentheses around this if we'd like. And then we said we're going to do plus 2 to move left, and then minus, right, plus 3, and then minus 2. So we'll do minus 2 here. Oh, no. All right. Tab, get back up there. This is supposed to be plus 3. And we can see, like, our graph, did it work? Yeah, right? It flipped over the... What did we break? Oh, we broke something. But you get the idea. We want it to flip over the axis, okay, and then shift down. So we're going to do, let's try that again. 2 caret negative x plus 3 minus 2, right? Flipped over the y-axis, shifted down and right, we're good to go, okay? All right, now we're taking y equals 1/2 x, reflecting over the x-axis. Remember, this means we're going to change the sign of the y, or f of x, all right? Then we're going 4 units to the right, so that means we're doing x minus 4 go to the right, and up 5 means we take f of x and we add 5 to it. So here we go, f of x equals, change the f of x, change the sign, so negative in front, okay? 1/2, that's our base, all right? We're going to subtract 4 from the x, so minus 4 to move right, and then add 5 to move up, and that should be our function. For C, we're going to identify the parent function. So the parent function is just because it's exponential, it's just the y equals, or f of x equals 2 to the x. Just the base times the x, that's it. Okay, and then any transformations. So remember, the negative in front is making f of x negative, right? We made f of x negative. We also added 3 to the x, and we did f of x, right, minus 5 here in the end. So what does each one do? What does each one do? This one is a reflection over the x-axis, not of, but over. We make the y, or f of x negative, reflect over the x. Plus 3 means we are going to translate or shift. Okay, 3 units, and it's the opposite of what you think, so it's plus. It actually moves left. 3 units left. And then the minus 5 means we are shifting, or we are translating 5 units down. Oh, I keep spelling that wrong. Okay. And then for D, same thing. Here we are doing negative to the x, so making the x negative. Okay. We're doing x minus 5, and then we're doing f of x plus 3. So remember, what does each one do? The first one is a reflection. Because we made the x negative, it's in the y-axis. All right. The minus 5 here is going to actually shift or translate. All right. And this is, since it's minus 5, all right, we are going to translate 5 units, and it should be moving to the minus. So that thinks would be to the left, it actually moves to the right. And then remember, the plus 3 on the end means we are also translating, translate. There we go. 3 units, and it is what it seems, it's up. Okay. And here's the graphs that we just looked at. So you can see we reflected it. We did the x negative, we reflected over the y-axis here. And you can see the graph actually shifted to the right, right? That was a minus 5 to the right. And then the plus 3 in the end made us go up. Okay, you can kind of see how that worked. So that's just checking on your calculator. You can kind of get the idea of how this is working. All right. Number 18, the car was purchased for $25,000. It depreciates at a rate of 18.5%. Remember, that's 0.185 as a decimal. All right. This 25 units is our A, our initial value here. And we want to make a function v of t for the car purchased after t years. Okay, so we know our function is supposed to be y equals ab to the x, but they're telling us to use v of t and t instead. Okay, so we know the a is 25,000. The b part, okay, is actually going to be 1 minus the rate, and the rate, because we're depreciating, is 0.185. So if we take that away, okay, that means we're going to get a b value of and it should be 81.5. So 0.815 is 18.5% away from 100. Gives us 81.5 of 0.15. That's our b value. Now, instead of using y, we're going to use v of t, and instead of using x, we're going to use t. So our formula looks like this. V of t equals 2,500, sorry, that's wrong, 25,000 times 0.815, which is our decay factor, to the t. And now we want to know how much will it depreciate from years 3 to 4. So really, we need to take v of 3, I should say, and subtract v of 4, okay? That's what we're going to do here. So v of 3 means we just plug 3 in for t. So 25,000 times 0.815 to the third. We'll do that in a second. And then v of 4 is 25,000 times 0.815 to the fourth, okay? So grab our calculator, new document. Don't want to save. All right, so 25,000 times, parentheses, 0.815 to the third. Okay, and then remember we can highlight that and change that 3 to a 4, and we'll have our other answer. Okay, so we have $13,533.58. $13,533.58 for the first one. The second one, v of 4, is $11,029.87. So we're just going to subtract. So we're going to do $13,533.58 minus $11,029.87. We can do that right on the calculator here. 13,533.58. That was 58. Minus 11,029.87. And we're going to get $2,503.71. $2,503.71. All right, and that's our answer. Okay, so the car depreciated by dollar signs, $2,503.71 from year 3 to year 4. We'll fix that in a second. A little too much undoing there. Okay, for the next question, here gives us a recursive formula. We just want to generate the first 3 terms. So we already know the first term is 4. So the second term, if you remember, is going to be a sub 2 minus 1, which is really a1 times negative 2. So this is a1 times negative 2. And then we're going to plug in. a2 is really 4, the first term, times negative 2. So a2 is equal to negative 8. Okay, the third term is going to be a sub 3 minus 1 times negative 2. And remember, 3 minus 1 is just a2. It's the term before it. Okay, so a3 equals a2 times negative 2. All right, that's times. So a3 is negative 8 times negative 2, and a3 is equal to positive 16. Okay, create an equation in the sequence of terms n and find the 10th term. So remember, this is a geometric. So an equals a1, and then we're going to multiply that times r to the n minus 1. All right, so an is a10. Actually, time out. We need to plug in to get the formula first because it does say create an equation. So an equals the first term, which is 4, times r. R we know is going to be this guy on the end here. And you can kind of see we're multiplying by negative 2 to get there. So it's negative 2 to the n minus 1. There's our formula. That's the first step. Now we want to do the 10th term. So a10 is equal to 4 times negative 2 to the 10 minus 1, or 9, okay? And then a10 is equal to, we take our calculator, we do 4 times, you can put it in parentheses if you want, we should, because we're going to raise it to a power, caret 9, and we get negative 2048. So a10. All right, and there is your review sheet. So I will talk to you guys tomorrow. Hope you have a great rest of the day. We'll see you later.